Okay, the question is, a small sphere of radius r falls from rest in a viscous liquid. From a viscous liquid, as a result, heat is produced due to the viscous force. So the rate of production of heat when the sphere attains its terminal velocity is proportional to. So these are the options. We have to choose the correct answer. So how will we be proceeding? First of all, let's revise the formula of the viscous force. That is basically, it is given by F is equals to 6 pi eta r Vt. Now what is Vt here? Vt is basically Vt is terminal velocity. What is Vt? It is terminal velocity. R will be the radius, and eta is the dynamic viscosity. Dynamic viscosity coefficient. Now what is the formula of Vt? That is terminal velocity. That is basically given by 2 by 9 r square rho minus into g by eta. So basically this is density. I am writing here rho is equals to density of the sphere that falls on the viscous liquid. Then we have, this is density of viscous liquid. Density of viscous liquid, and g is the acceleration due to gravity. G is acceleration due to gravity. Rho is density, and these both are densities, but this is density of the viscous liquid and this is the density of the sphere that falls on the viscous liquid. So basically the formula of the work done is work is equals to force Vt, okay, where Vw is work done. Now basically we'll be substituting the formula of viscous force in this. Fvt, that would be W equals to dq by dt, work done, that is 6 pi eta r Vt square. So now after substituting the formula of terminal velocity in the above equation, we'll be getting now Q is equals to 6 pi eta r, and we'll substitute the value of Vt here, that is 2 by 9 r square rho minus sigma g n whole square. So by simplifying the above equation, we'll be getting this equation, we'll be getting dq by dt is proportional to r raised to power 5. So our answer is r raised to power 5, option number 3.